3.5 has to do with rhombus. A rhombus is a parallelogram with two consecutive, meaning next to each other, sides congruent. Let's review our properties of parallelogram. In a parallelogram, we know that opposite sides are congruent. So AB is congruent to CD, and BC is congruent to AD. We also know that opposite sides are parallel. So we have AD parallel to BD. We have AB parallel to CD. We know that opposite angles are congruent. So angle A is congruent to angle C. Angle B is congruent to angle D. Because it's a parallelogram, consecutive angles are supplementary. That one's a little tougher to mark in the diagram. And the diagonals bisect each other. So if I draw in diagonal BD and diagonal AC, it does not say they are equal, but they bisect each other. And I can tell they're not equal. The yellow one, BD, is clearly longer than that brown one, AC. Now, I just told you by definition that in a rhombus, two consecutive sides are congruent. That means that AB is going to be the same as a consecutive side like BC. Well, BC is the same as AD, and AD is the same as BC. All four sides are the same. So that's our first special trait for a rhombus. Since it's a parallelogram with two consecutive sides congruent, we really know that it has four congruent sides. All four sides are equal. Now, once all four sides are equal, we have some other properties that kind of happen. Inside of the rhombus, we now have four triangles, and all of those triangles are exactly the same size and shape. I tried to zoom in on it a little bit too much. So we have four triangles in here, and each of those triangles happens to be a right triangle. So what I know right there is those are right angles, and that is because the diagonals are perpendicular. I'm going to write down that we have four right triangles inside a rhombus. Important to note, because in right triangles we have a squared plus b squared is c squared. So the Pythagorean theorem is going to be hiding inside of the rhombus in four different places that could happen. And the other thing that we have in a rhombus is if I draw this rhombus without all of the markings and I just draw in one diagonal, we see that we have two congruent sides. Now, focusing on just that half of a rhombus here, we have two congruent sides. Take a look at that triangle. I'll rotate it around. Looks like that. It's isosceles. So we have isosceles triangles inside of a rhombus, which means this angle here matches that angle right there. But it's a parallelogram. In parallelograms, alternate interior angles are congruent. So this angle here, make it orange, has to match that angle. Those are alternate interiors. This matches this. Those angles are equal. That means that that yellow diagonal bisected angle ADC. So the angle was cut in half. So the two extra properties we have of rhombus are that the diagonals are perpendicular and that the diagonals bisect the angles. So those are properties that we can use to